Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is meant as a review for college algebra and students in a pre-calculus class, and the review is on piecewise-defined functions, specifically graphing piecewise-defined functions. If you already know how to graph piecewise-defined functions, there's going to be nothing new here for you, with the exception of possibly how the domains are written. So you might want to stick around for that. There's only one example I'm doing, so this should be somewhat fast. So to graph a piecewise-defined function, you should already know, just graph all pieces at once and then liberally use erasers. So I'm going to start by just graphing out an X and a Y axis. The next thing I'm going to do is actually note the scale of the axes. So for example, the X axis, I see that the first condition is X is less than -2. The second condition is bordered around the absolute value of X being less than or equal to 2. I need to talk about that. That will imply that X itself is less than or equal to +2 and greater than or equal to -2. So that gives me another range of X values I have to worry about. And then finally, the last conditions for all X values greater than 2. So as far as labeling my X axis, I'll just go ahead and maybe go from -4 to +4. For convenience, I've just used little dash marks there for that. Not a big deal. Next thing you have to worry about are the Y values, the associated Y values for these functions. And this can be pretty terrible because you have an exponential function here, e to the negative x. So let's consider, at least for the X values we've graphed, what that e to the negative x is going to look like. For X equals -4, we'll have e to the -4th. That is e to the 4th, and that's somewhere between maybe around 25 and 81, somewhere in there. That's a big range of values, but you can tell that the Y values are ridiculous there. And in fact, it is around a 54. So I'm just going to say it's approximately 54. It's not exactly. And in fact, really, it rounds to 55. And then as far as X being a +4, e to the -4 is going to be something around 0. So as far as the Y values for that function, they range from something around 0 all the way to something around 55. I'm just making a little note to myself so that I know the ranges that I have to worry about. Now X squared, on the other hand, from -4 to +4, well, when X is -4, the output is 16. When it's +4, the output is 16. In the middle, the output is 0. And then finally, the linear function, which is kind of the easiest. At -4, that's going to be 9. At +4, it's going to be 1. So obviously one of these kids is doing his own thing. This guy right here, the Y values are super huge. So we have to scale these axes kind of oddly here. Now remember, e to the negative x is what the function will take on if x is less than -2. I don't actually have to go all the way to x equals -4. I could start at x equals -2 itself. And if I did that, well, e to the -2 is a bit more manageable. It's around 7. And e to the -3 is around 20. So it might be better to really graph that exponential function from -3 all the way to +4. It's a little bit easier to handle. So let's go ahead and graph the first function, and we'll graph that one in red just because I'm using different colors here. So I'm going to go ahead and scale my Y-axis accordingly. Again, I'm really only going to worry about the Y values getting up to a height of around 20. Now the scale that I'm using here, it's going to be in 5s. So let me mark that in. And while I'm at it, I might as well write down the X-axis values. All right, so the e to the negative x. Well, at -3, e to the negative x is roughly 20. And that's what this point will represent right here. And then at e to the negative, sorry, not e to the e, but e to the -2, which is e to the +2, we get that at -2, the output's around 7. So again, I plotted that in there. And then e to the -1 is e to the first, which is 2.718 and some change. And then at 0, e to the 0th, or -0th in this case, would be 1. And then e to -1st and e to -2nd and so on and so forth. They get closer and closer to 0. Just remember that e, the exponential function, is not ever going to actually be 0. It just gets really close to 0. So that red graph is actually the graph of e to the negative x. There is a little bit of ink that spilled over below the x-axis there. Ignore that ink because honestly, e to the negative x will never touch 0. Now we move on to the second function, which is just x squared. That one's actually easier. So we know at, let's go ahead and start at -4. At -4, x squared is going to be 16. And I don't need to do all the values. I'll just go to -2. When you plug in -2 in, the output should be 4. And when you plug in 0, the output should be 0. And when you plug in 2, the output should be 4. And finally, plugging in 4, the output should be around 16. Connecting the dots with a nice smooth curve. And so in green, we have y equals x squared. Now, finally, we'll do the last one in blue. In blue, we'll graph -x plus 5. That's a simple one. I actually have a ruler here to do that, right? It's up 5 units, but it decreases at a rate of 1 for every 1. So the slope is -1. Now, I totally get it. If you look at that blue line and you're like, wait a second, that does not look like a line that represents a slope of -1. It's because the scale on my two axes are completely different. The scale on my x-axis, it's scaled by units of 1. The scale on my y-axis is scaled by units of 5. And so it's a little off kilter, but that's just something you have to get used to. Now that you have graphed out very accurately and very carefully all 3 functions, now you erase where those functions should not exist. For example, that red function, e to the negative x, we will only keep that graph if x is less than -2, specifically strictly less than -2. So at x equals a -2, I'll put a little open hole in our red graph, but otherwise I will erase after that. All right, so that gets us there. I tried to be somewhat careful, but you can't help but erase a little bit much. Anyway, the next graph, which is the green graph for x squared, that will keep as long as x is between -2 and +2, and we're going to keep those edge points too. So there'll be solid dots on that curve at x equals -2 and x equals +2. I'll start with the solid dots. Now that I've put the solid dots in there, I will erase away the graph. So that's a pretty decent look at the graph so far. We got the green done. Now we're off to the blue, and the blue only exists for x greater than 2. So at x equals 2, there'll be an open hole there. Otherwise, I can erase that graph. And there you have it. That's a really good graph of this piecewise-defined function, scaled appropriately. That's kind of the level of detail you need to have when you're graphing a piecewise-defined function in a mathematics course at a college algebra or pre-calculus level. I suppose you could label these points, but I think my axes are just good enough to where you can actually see the values anyway. So that's a really, really nice graph. That's what I would expect my students to do, the quality that I would expect from my students. So please, if you're one of my students, do that. All right, we are done. Very short video, right? So, but this is just a good reminder of how to graph a piecewise-defined function. All right, I'll see you in the next video.
It's the system of equations. We must deal with them all at once. Always always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.